Hello guys, Axel here, and welcome to Pinpoint. This is what the module will look like. It should be selected between three coordinates, all with three numbers. Three separate numbers, one for each one, appearing. These numbers will be referring to distances from a mystery point in this grid relative to each of these points. And the aim of the module is to figure out what this mystery point is. These numbers that we're seeing here are the distances, but scaled by a scale factor. Of course, we don't know what that scale factor is, so possibly trying to trust just eyeballing it might not be the best idea. So, to remove that factor, since this is what it will look like, given A and B are mystery point that we don't know yet, the distance without the scale factor will be this, and then with the scale factor we get the number it shows here, 2 3 decimal places. So what we can do is select two of the points, find the ratio of those distances, and since they're both scaled by the same scale factor z, if we take the ratio of them, we get rid of that scale factor, so we can just guess A and B without needing to know what that scale factor was. Of course, these are truncated to 3 decimal places, so when we use something like text field calculator, we might get slight deviation in the answers, but if we get close enough, we can assume that could be our answer. However, do be careful, because, of course, if you have to go through a point, or you go past a point, basically, the distance can get smaller and then grow again, and that means sometimes the ratio can get smaller and then grow again, or get bigger and get smaller again. So, with our method, you can see here, I've only labelled 2 points here, because we're only taking the ratio of 2 of the points. As soon as we get a possible answer within a certain degree of accuracy, about 3 decimal places, we should double check it with the third coordinate by plugging that in as one of our x1, y1 or x2, y2. x1, y1, x2, y2 being the same as a and b in that sort of format. Placing it with the third coordinate and seeing if it still makes sense. If it doesn't, it means it's probably a similar point but on the other side of the point we found. So it's sort of like going through a point to the other side of it. So, before we get started with guessing and checking these, let's note down these 3 positions and then note down what order their distances are from the mystery point. So we have C5, F3, and C9. And the distances we have 16, I think that was, 7, 16, and 22, meaning this is the closest, this is the second closest, this is the third closest. So we can assume we're looking sort of this bomb-ish area, closer to 1 and 2 here rather than 3. So we don't really need to check up here, for example. However, we can guess down here, but we don't need to look up here. We probably don't have to look down here because it's closer to these 2. But there is a good chance it could be one of these ones up here as well. So let's start with the larger area. If nothing makes sense here, we'll move up into this top left corner. Or really the top part here. It's only really the bit down here that we know isn't right. Actually, even more, we don't even have to go that far down here, because at some point it's going to be closer to 2 and 3 here as well. So effectively, in reality, we're not looking at this bottom right part. I apologise. We're probably looking up in the top here. So let's just start from A1 and go across like that. We should hit it soon enough, knowing that we probably don't have to venture anywhere down here. We're probably not going to really get past row 4, maybe row 5 at a push. So let's select F3, 6 3, and C5, 3 5. And the ratio of those ones was 16.324. And that's 7.700. So this is the ratio we have currently. We haven't guessed anything yet. This is just... I think this is plugging in 0 for this. Let's see. I don't know what it's doing then. Maybe one of these is already defined. But now let's guess with just A1 to begin with. Of course, that's not going to be exactly right. And now let's change the lettered coordinate, so changing the top one here, and seeing if any of those is within a reasonable distance between to our ratio that we got. So 2, 3, 4, 5, 6, 7. No, it's gone past it. So let's move down a row. And again. Gone past it again. Although it is getting bigger again. Ooh. Actually, this is looking good. This is why, since we got close to this point and went away from it again, the number got sometimes gets smaller and bigger. So let's test out this with the third coordinate we have, which is C9, so 3, 9. Change this to the 20. Okay, this makes sense as well. 22.449. So we can be reasonably certain now that our answer is going to be this. Translating this back, this is I2. So to go into submission mode, we just click on the screen, and then we get full control of the thing that was moving around. And all we have to do now is click on the square we think it is, that being I2. And if we're right, we get the self module like indicator and get a self module. So let's do another example. I think I saw it, so as we go down, this box is not moving that much actually. So unfortunately, I think that means that our region to check is either going to be really small if it says up here, but could also be really large if it is pointing more down here. I actually don't know if it can point down here actually. It's probably going to be somewhere up here or up here. I'm not looking at the numbers yet. But let's see. Let me reset this. So this time we have J3 and J4 and G3. And then the closest, that's 50.43.4. So that's 1, 2, 3. So I think my worry is correct. Given that this one's the furthest away and these two are closer, we're probably looking at a sort of big rectangle here, and the number's quite big as well, so we're probably looking down here somewhere. So it might be within our interests this time to sort of work from the bottom up rather than top down and prioritise looking on this side, maybe. It might actually be more likely on that side. I guess we'll see. So let's pick our coordinates. Just for... Let's go with these two so we're not just focusing on two next to each other. So J4 or 10-4. And then G3, 7-3. The ratio of those is 43. I think it's that. .568. Do we want the 3 and the 8 are difficult to tell apart? I think they line up with the thing. 43.568. Then 2 was 44.832. Okay. So let's work from this corner going upwards. Thankfully, since they're sort of pressed up against one side, we're probably only looking for when it goes below it, and then we can safely move on to the next one. So we have 110. And then we're moving left and right, so I'm changing A again. 2, 3, 4, 5, 6, 7. Went below. Move up a row. 1, 2, 3, 4, 5, 6. Okay, 7, 9 is within a reasonable sense of accuracy. So let's look at J3. .123. Okay, within a reasonable amount of accuracy again. Meaning, again, we can probably be safe to assume we've found the right point. Translating that back. 7, 9. The second one is always going to be the same as the number. This is going to be transformed into its respective letter, which is G. So the point we were looking for is actually G9, so it's actually in the same column as this one. Yeah, G9. So clicking again, getting control, and then going to G9. We get another module. So that was Pinpoint. I'll admit this probably isn't the fastest method to do it because it is sort of guess and checky, but it does get rid of the scale factor problem. And doing this first at least gives you a rough idea where you're looking. Even if, in this case, it gave us pretty much the entirety of the bottom left here. We still could figure some stuff out, such that since the lower ones were pressed up against the wall, sort of, meaning we didn't have to worry about it going down and back up again, or vice versa. Don't know if it actually can go up and down. Might just go down and up. It changes direction, let's say, just in case both can happen. But hopefully, Pinpoint makes a bit more sense now. And I'll see you guys in the next tutorial. I'll see you later.